what here? 2. You know why I did that? Because that is the maximum s orbital can contain. Regardless of whatever the number is, that is not your business. Our major business is that whenever I see the s orbital, that the maximum it can contain is 2. So I will write 2 here, right? Now I'm through with the first arrow. You will now get to the second arrow, which is 2s. Remember, why doing that? Carbon is 6, Yabi. Out of this 6, you have removed what? 2. How many is remaining? 4, right? So because you must make sure that these 6 electrons are exhausted. So what will you do? You have picked this. Now you will now get over to the second line. Now in the second line here, what are we having next? Is 2x. So I will write what? 2s. Am I communicating? Now this is the 2s now. Now remember that you have removed 2 from this 6. So what is remaining here is what? 4, right? Okay, now since you still have up to 4 electrons, you will now ask yourself, okay, how many this is s orbital. Remember our rule, the maximum is what? Is 2. So you will give it what? 2. Can you see it now? Now you have removed 2 out of 4. How many is still remaining? You still have 2 that is still remaining. So you are through with the first line, you are through with the second line. Now you will now get to the what? Third line. Now on getting to the third line, the one that we pick is the first one that you are seeing here, which is the word 2p. So you will now write the next one is what? 2p. Now when you now write this 2p, this 2p, remember you remove 2 from 6, 4 remain, Abi. Out of this 4, you remove 2. How many is remaining? Now what is remaining here now is what? 2 electrons. Okay, now you will now ask yourself, for p orbital, the maximum number of electrons for p orbital is what? 6. What does that mean? It can contain 1, 2, 3, 4, 5, but whenever it is up to 6, you stop there and get over to the next energy level or to the next orbital. So for our p orbital, so I will now pick 2p. Now how many electrons is remaining? 2 is remaining. So I'm free to give it what? 2. Because that is actually what is remaining there. Now count this. Now if you count this number, they must be equal to what? 6. So it's very simple. It's all about you following this particular words order. Okay, now let's do another one, like something like, let's say sodium. Now remember, the first question you will ask yourself is, what is the atomic number of sodium? Because it's very important that you know the first 20 elements whenever you are dealing with this type of topic. Okay, now sodium. Now the atomic number of sodium is 11. The atomic number is what? 11. Now let's follow our rule. I have already said this. Look at this, 1, 2, 3. So we pick the first one. The first line here is 1s. So you now write 1s. The maximum number of electrons for s orbital is 2. So I will write what here? 2. I'm through with this 1s. We pick the next one, which is what? 2s. For that is, they are all still s what? Orbital. The maximum number of electrons is still what? 2. So you write what here? 2. Remember, as we are doing that, you have to take note of how many electrons that is remaining, because you are working based on the given number of electrons that particular element has. So out of 11 electrons, 2 plus 2 is 4. We are giving out 4. So how many do you think that is remaining? What is remaining here is what? 7. So we are done with this. We are done with this. You will now get over to the third line. In the third line, the first thing you are seeing here is what? 2p. So you will now write what? 2p. But we still have up to 7 what? Electron, right? Now remember, before you can pick 3s, or before you can get to this 3s, because I have already said that when you get to the third line, you must make sure that you have filled this one first and this one before you can think of going to the next line. Now in the third line, you will pick the first one that I see here, which is 2p. Now look at this. We have 7 electrons, right? Now the maximum number of electrons for p orbital is what? 6. And I still have up to 7. So what will I do? I will give this guy what? 6. You cannot give it 7 because we have already said that it can contain 1, 2, 3, 4, 5, 6. But it shouldn't exceed what? 6. So I will give it 6, Abi. Now on giving it 6, you will find out that 1 electron will still what? Remain. Now you have picked 2p because you must finish this line. You can see this line here. It has 2p and what? 3s. Before you think of getting to the next one. So I will pick what? 3s. So you now write 3s. Now, how many electron is remaining? What is remaining here is just what? 1. So I will write what here? 1. Because of course, s orbital can contain 1 or 2. But for s orbital, it shouldn't exceed what? 2. So count it. You will now have 2 plus 2 is 4, 6 is 10 plus 1, 11. Because when you count them, it must be equal to 11, which is the atomic number of that element that you are working with. Okay, now let's look at the next thing. How can we use this? How can we use SPDF, to determine the electronic configuration? How can we use this SPDF to determine the group and the period of an element? How can we do that? Now, it's very, very simple. Look at this. It's very, very what? Simple. All right, I have to